Okay, here's your notes for the second part of lesson 1.5. We're talking about graphs of functions. We already did day 1. This is day 2. Day 2, we're going to talk about relative minimums and relative maximums. And instead of drawing out and writing an entire description, I'm going to just show you the picture, because a picture paints 1,000 words. You can see here there are 2 different relative maximums, 2 different relative minimums. Relative meaning what is the minimum in that area relative to this area of the graph. There's a minimum relative to this area of the graph, and there's a minimum. There's 2 different relative maximums right there. Now, at any point as we go through these notes, pause it, rewind it, take the time to draw whatever it is, or write, because I'm just going to keep going through each slide. You're going to use a graphing tool to approximate the relative minimum and relative maximum. Here's the function, f of x equals 3x cubed minus 4x minus 2. Go ahead and pause the video and take the time to put that into your calculator. Here's what it should look like after you type it in, 3x cubed minus 4x minus 2. The graph. From the diagram, again, a picture paints 1,000 words. You should be able to find one relative maximum and one relative minimum. The actual maximum goes to infinity. The actual minimum goes to negative infinity. We have to find the maximum in that area. So we're going to calculate, second calculate, and you've got the options right there, the minimum and the maximum. We want number 4, the maximum. Okay, because it's relative, we can't just find the maximum on the whole graph. We have to find the maximum in an area, and it's asking you, what is the left boundary? Well, right there, it's too far to the right. If we want to know in the general area, the left boundary and the right boundary. So we're going to trace over, just right arrow, or left arrow. Don't go too far. Okay, in this general area, somewhere between negative 1.5, and yours can be anywhere in that area, hit enter. And now it wants to know, where will your right boundary be? My left boundary, you have to get your right boundary over to the other side of the relative maximum. Somewhere, just make sure you're around the corner. Hit enter again. It's going to ask you if this is a good area to guess. This is not your answer yet. It gives you either the 2 tabs, or in my case, the dotted lines. Is that the area where you want to find the maximum? If that's good, then go ahead and hit enter, and it will give you the maximum. It looks like the maximum happens at negative 0.66666666, which you all should know as negative 2/3. And it went down 0.222222, which you can change that into a fraction if you want to, as negative 2/9. Okay, is it wrong if you do negative 0.67 and negative 0.22? No, it's not as exact, but sometimes it'll ask for decimals, and those can be your 2 answers. That's your relative minimum or maximum, and it says right up there. Now we're going to go to the relative minimum. Same idea. Calculate. This time the minimum, number 3. You have to get a left boundary somewhere to the left of that minimum, of that valley. Hit enter. Go around and keep going until you get to the right side of that area. Hit enter. Should it guess in this area somewhere around 1.2? Yeah, that's a good guess. In that area, it's around that minimum, and then your cursor blinks exactly on the minimum. Your minimum is over here at positive 2/3, or 0.67. So it's the same distance away. This one went left, that one went right, but now this one is down 3.78, rounding to the nearest hundredths. There's your relative minimum. Okay, next topic is the average rate of change for a nonlinear graph. What if it's not a line whose slope changes at each point? Depending on which point, you're going to have a different slope. So you need to find the average rate of change between the 2 points. If you can find the average rate of change, that'll be the slope of the line through those 2 points. How do we find the average rate of change? Again, pause it if you need to, so that you can write all that down. Here would be an example. The blue line is a nonlinear graph. We want to know the average of the slope of that graph between those 2 points. So we need 2 points on a graph. The line itself is called a secant line. And the slope of this line, instead of just calling it m for slope, you have to call it m with the subscript of secant, S-E-C. The secant line, which will give you the average of the slope of all of that line. If we were going to draw it, we would have, here's the slope, here's a 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 slope. We'd have to calculate all those different slopes and add them up and average them. But instead, we just pick 2 points, get the average of there. The average rate of change, that should look very familiar as the slope formula. The only difference is that it says m with the secant, so you know it's not exact. And instead of using y2 minus y1, we write it as a function, which you're getting used to that notation. Take the value of the function minus the value of the other function at that point, and x2 minus x1. On the side, if you want to write it as y2 minus y1, that's okay as well. Here's an example. Find the average rate of change of f of x, which is x cubed minus 3x. There's your function. From the first point, negative 3, to the second point at 0. We know our domain. We know we're going to go from negative 3 to 0. We do not know the range yet. We have to figure out the range or the f of x values. We need 2 values up here. So let's find, since they do the second one, let's find the second one first. Take the 0, plug it in for both x's. So f of 0, 0 cubed minus 0 is 0. This second one, what's the value at negative, or at the first x, which is negative 3? You're going to plug that in there and plug that in there. F of negative 3. Go ahead and do the calculations. Negative 3 cubed is negative 27 plus 9. You're going to get negative 18. Those are the points that you're going to use to do that slope formula up there. F of x2. Here's our second x, or our second f of x, 0. Minus the first one, negative 18. Make sure you minus a negative. Go in the same order. x2 is 0. Minus x1 is negative 3. Do that on a calculator or in your own head. You get 18 divided by 3. They're both positive. And the slope of the secant line is 6. 6 over 1 if you had rise over run, but you got to reduce it all the way to just 6. So that would be the average rate of the change of the graph. If you wanted to graph it, you could. I'm not taking the time. Next topic, even and odd functions. Even and odd functions. A function is even if its graph is symmetric with respect to the y-axis. Here's your y-axis. It is even if whatever happens on one side of the y-axis has a mirror image on the other side of the y-axis. It's symmetric. It's called odd if its graph is symmetric with respect to the origin. You would think even would be y-axis and odd would be x-axis. That's not the case. With respect to the origin, it's odd if whatever happens up here also happens down here, reflecting around the origin. If it happens in the second quadrant, then it also happens in the fourth quadrant. If it happens in the first, it happens in the third. The tests are the same as they were for symmetry. If you're doing an even test, it has to be symmetric with respect to the y-axis. So if you plug in a positive x value, you should get the same exact answer as if you plug in a negative x value. Your y's should be the same. They went up the same distance. X becomes a y, but negative x also is y. If it's odd, they both change. If you plug in a negative x, you would get a negative y, and a positive x, positive y. They both have to change. We already did examples of those with symmetry. We can do another one here. The function g of x equals x cubed minus x. Is it odd? Is it even? Or is it neither? So to do the odd test, no, we'll do the even one first. The even test, if its graph is symmetric with respect to the y-axis, change the x into a negative x. See if you get the same answer. Use your store key, or just do it by hand. Make sure you use parentheses. Minus negative x. We test it. We say, all right, if I have a negative 3 times, negative times a negative times a negative is still a negative. A negative times a negative here becomes positive. Since that is not equivalent to the original problem, then it is not an even function. Or it is not symmetric to the x-axis, to the y-axis. Let's check for odd. If we're checking for odd, we'll go with g of x equals a negative x cubed minus negative x, but we have to change both of them for an odd function. If you'd rather call this a y instead of a g of x, I'm okay with that. You have to change your y into a negative y. They both have to be equivalent to the original function. So let's see what happens here. We get negative y equals negative x cubed. We already know this one because it's up there. Plus x cubed, or plus x. Aha, take a look at this. You have a negative y over here. We can't have a negative y. We have to have a positive y, or a positive g of x. So I'm going to change this to plus, which automatically changes everything on the other side of the equation. Changing it back to g of x, this becomes an x cubed, and this becomes a negative x, which is exactly the same as your original function. Is it odd, is it even, or is it neither? It is odd. It's going to be symmetric to the origin. If you graph it on your calculator, you will see the symmetry with respect to the origin. Back up, you might be asking, well, why can you just change all those? All I really did was divide by negative 1 to get rid of the negative y. Dividing by a negative here, divide by negative 1, you have to divide by negative 1 there, and also there, which changes all the signs. Last one, let's try this one. H of x equals x squared plus 1. Is it odd? Is it even? Is it neither? Again, pause it if you need to. Take the time to write it down. We're going to go with h of x equals negative x, in parentheses, squared, plus 1. What happens when you square a negative? It becomes positive. Therefore, this is an even function. It is symmetric to the y-axis. But you also have to check for the origin, because what if it's both? Could it be odd and even? Change the h of x into a y. We'll make it negative y equals negative x squared. Changing both the y and the x to a negative. You get negative y equals x squared plus 1. You can't have a negative y, so once again you have to divide by a negative 1, which will change this sign, and we'll change this sign, and we'll change this sign. That is not equivalent to the original equation. So it is not odd. Graph it, and you'll find out it's an even function, because it'll look like this, and it'll be symmetric to the y-axis. Always check your answers. Graph them, do whatever. All right, go back and review your notes. Don't just write them down. Please don't just write them all down and then not know what it's doing or what it's saying. Go back, rewind, review, pause it. Understand odd and even functions, symmetry, average rate of change, and relative mins and maxes. And you can practice more of these problems. Just put your own function in there and make sure you know how to calculate. You should write on your notes, how did you calculate the relative min and maximum? Because what if you forget when you're trying to do your homework or you're trying to do your quiz? Write down the steps that you used when you calculated the relative minimum and the relative maximum. Where was that on your calculator? Because if you ask me during a test or a quiz, I'll say, well, how'd you do it in your notes? How'd you do it in your homework? You should practice it enough that you know how to do it. When you finish, you can go ahead and get started on your assignment right away. Put your Chromebooks away. Page 63, 39 through 75, you're doing all of the odds. Check them in the back of the book.